Hello everyone and welcome back to this new video of Agentic AI series. Up to this point in this series, we have explored the building blocks of Agentic AI, models, memory, tools, orchestration frameworks, and so on. But here's a key shift. None of these components on their own makes a system agentic. Today, in this video, we move from components, from structure, to something more fundamental, capabilities. Uh, Answering the question, what can these systems and these components actually do when everything comes together? So let's make this more explicit. We know that the large language model LM is a reasoning engine. That's very true. We know that tools are the interface to the external world to execute actions. We know memory is where we store context, where we retrieve knowledge, and so on. But none of these elements or components create the autonomy. And we know that autonomy is one of the core characteristics that gives a system or an agent its agency. Agentic systems in general are not defined by what they are made of. They are defined actually by the behavior they exhibit. And those behaviors emerge only when those components are composed into a system. So, what are these behaviors that we are talking about? An agentic system is one that can plan, can use knowledge, act, adapt, and collaborate. These are not the features that we install in the system, but they are the capabilities that they emerge from the system design itself. Here in this simple diagram, we see the minimum viable agentic loop. A system receives input from a user from external world. It plans what to do, then it executes actions, observe results, updates the memory, and then looks back to replan. It loops back uh, on the same loop until the final result is achieved. This loop transforms a static system into a dynamic one, and everything we will discuss next is essentially an enhancement of this loop. So, to make it a little bit clearer here, in the loop, when we say planning, we decide actually what actions to be taken. And when we talk about execution, we are talking how we connect to tools and external systems, the way we perform the actions. Observation brings back result, and reasoning on those results. Memory stores the context and the history in a structured way, and the loop itself is critical. It's important here to understand this is not a linear workflow. It's a continuous behavioral system that adapts over time. And this is what we mentioned in the beginning, that there's a behavior emerging from the agentic loop that what gives a system its agency or its agentic identity. Now we move to the capabilities. Planning is the first and arguably the most defining capability of an agent. At its core, planning is about transforming a goal into a structured sequence of actions. But in modern agentic systems, planning is tightly coupled with reasoning. And here's where things gets a bit more interesting. In reasoning and planning, we have several paradigms that have emerged, like chain of thoughts, where we have the model reason step by step before answering or executing the plan. Tree of thoughts, where instead of having single reasoning paths, we have multiple branches where the model explores them, evaluates them, and selects the best one. And this introduces search into reasoning. Third paradigm that we have is a graph of thoughts, where extends the tree of thoughts into further structure by allowing nonlinear reasoning structures where ideas can merge, revisit, and evolve. The last one that we could see here is the react, reason and act, where interleaves reasoning with actions, allowing the agent to think, observe, and refine. Think, act, observe, and refine iteratively, and this intercouple interleaves the planning with action at the same time. So what we see here is actually is a progression from linear reasoning and planning to branching to structured search to action integrated planning. And if we look back of what we have built in the previous videos of the core components, we have built primitive versions of these paradigms. When we use structured prompts, when we build agents in LangChain or in LangGraph, when we build iterative loops, and so on. So here it's important to think of planning as it's not just what to do next. Actually, it is how the system explores the space of possible actions and how it selects the best one to do next. This is what we call planning. And the more advanced the planning strategy, the closer the system gets to a true problem solving point. The second core capability is knowledge management, which is what grounds the agent in reality. Without it, the system operates purely on its internal statistical representation of the world that the system was trained on. And with it, the system becomes context aware and adaptive. In modern knowledge management systems, we know that this goes beyond simple retrieval. We are not talking about retrieval only, but there are several layers of this. We can talk about the RAG and its different versions, the retrieval augmented generation, where the system retrieves relevant documents or chunks and injects them into the context window. This is the baseline of this RAG kind of domain, let's say. And then we can speak about advanced retrieval strategies, hybrid search, semantic and keyword search, re-ranking models, query rewriting, and so on. Moving forward, we can speak about here the context engineering, and where we decide what to include in the context window as core step here and a very critical step and as important as the retrieval itself. And this will include for us the search strategy, the chunking strategy, the document management, the window management, the compression, the fading out, fading in, and all of these elements of managing the context window and what goes inside it. And then we can here speak about long-term memory versus short-term memory. In the short-term memory, where we store the conversation context, history, and so on, and in the long-term memory, where we use vector databases, structured storage for longer-term and more persistent knowledge storage. Knowledge updating comes as one of the core elements of knowledge management, where the system can write back to memory, not only read from it. And this is very crucial, so the system can adapt from its own experience and learn from it. Now, if we connect this to the previous implementations that we have seen while we were working with the core components, we can see that we used vector databases, we used Yama Index and similar tools. We worked with the conversation memory, context window, and we use the short-term versus the long-term memory, and so on. We were building the knowledge layer there on all of those implementation, also in very primitive version of it. Here's actually the what I would call it the deeper insight. Knowledge is not just about storage. It's not knowledge is not only stored in a memory. Knowledge should be curated, filtered, shaped before reasoning, and this is where many agentic systems fail, because what the model sees defines what the model can think and reason on, and that leads actually the whole behavior of the agent. So if we are using poison context or irrelevant documents or relevant knowledge, the system will behave totally differently from the objective that is designed or asked to perform. Yeah, the third capability here is execution, which is where the agent crosses the boundary between cognition and action. This is the moment where reasoning produces real world effects. And because execution is not just about calling tools, it involves critical sub capabilities. We can notice three of them here. First of all, we should count for tool selection, which is where the model must decide which tool to use among many options. And this is a classification and reasoning problem to be able to select the proper tool at the proper time. The second subcapability is the parameter generation, when the model must generate valid and precise inputs for the tool, and this requires structured input and constraint handling for that input. The third one is action sequencing, when we are dealing with complex tasks, which usually require chaining multiple tool calls in the correct order to achieve the final objective of one function or one request. In modern systems, execution is enabled through function calling, tool abstraction layers, API orchestration, and so on. We have seen that in different versions through LangChain or other kind of frameworks that help us manage this flow. Uh, Here, just another shift as well, that execution transforms the system from a passive responder into an active participant in the environment. And this is really a crucial threshold that we need to pay attention to, because once we cross that boundary, we are not just building or generating text anymore. We are operating systems with real effects in the real world. And this is really important to keep in mind when designing agentic systems. Error handling and recovery. It is where the systems move from being impressive to being reliable and trustworthy. In real world environments, failure is not an edge case. Totally, it's not the case. It is the default condition that we should design systems around, because the systems will fail for sure. So our question should not be, will this system fail or will this agent fail? To a question like, how does this system or this agent respond when it fails? Because it will fail no matter what. And in modern agentic system, uh, this question is answered through several layers to address the error handling and recovery process. First of all, we see self-reflection and self-critique, where the model evaluates its own output, and techniques like reflection allow the system to iteratively improve its responses. Second mechanism, we can see verification mechanisms using rule-based validation, external validators, or cross-checking output, and so on. Third one, we can talk about the retry and backtracking, where the system can attempt alternative strategies when one of the strategies fail. And this, if you remember, connects back to the beginning of this video when we were talking about the tree of thoughts and search-based reasoning and the graph of thoughts and so on, where we can replan and refine our plan based on the execution, how it moves. And then we can talk about uncertainty handling, where the agent can recognize when it lacks information and trigger retrieval or clarification, as probably asking for clarification from human input or from other system or from other agent, uh, according to which was assigned the task to that specific agent. Now, if we look back to what we have built in our previous videos, we have built early versions of the guardrails, we have structured outputs, and we implemented retry loops. And these were early forms of this error handling and recovery. Here is an important idea to keep in mind as well, that intelligence or agency is not defined by the correctness in a single step, but is defined by the ability to converge toward correctness over time. So it's important here to link that to the beginning of the video when we're talking about behavior over structure or over destiny. The whole behavior that the agent exhibit that moves the agent or converges the agent towards correctness over time. And we know that this convergence is driven by the feedback, by reasoning, by observation, reasoning, and feedback loops, as we were explaining. Multi-agent collaboration is the last one of these capabilities that we are talking about, and it is where agentic systems begin to resemble complex organizations. Instead of having a single reasoning process, a single agent, we distribute this cognition in across multiple specialized entities. But for sure, each agent can have its own prompt, its own tools, its own memory. That's the core of the agentic character or identity. But this enables as well several powerful patterns as when we talk about multi-agent collaboration. First is the role specialization, as one agent plans, another executes, another evaluates, and another feedbacks. It depends on the role assigned to each of these agents. Another pattern is debate and consensus, where multiple agents propose solutions and critique each other. This improves the robustness and reduces the bias in the system. And we can talk about as well parallel exploration, where different agents explore different solution paths simultaneously, especially in the reasoning and planning before moving to actions. And we can see as well another pattern, the hierarchical coordination, where a manager agents delegates tasks to worker agents and aggregates results and so on. Frameworks like CrewAI or AutoGen formalize these patterns explicitly, uh, but there's a key shift here before moving to how we implement that, is in the thinking of it, that a single agent system is a cognitive unit, while a multi-agent system is a cognitive ecosystem. And this is where emergent behavior becomes visible, because the interactions between agents can produce outcomes that were never explicitly programmed. And this is where we start to see agents, societies, and this is where things becomes more human-like, actually, in the human language, if we may say. We will start to see societies that resembles the human societies. Now, if we get back to the loop and bring everything together, we can reinterpret it in this way with while enriched with these capabilities. So we can see planning, driving decisions, knowledge informing reasoning, execution acting in the world, error handling ensuring robustness, and multi-agent scaling the intelligence that we are building. And this is really where we can see real agentic behavior coming from multiple agents collaborating to um, achieve one shared vision of these agents rather than only one goal or one task. So with this, what we ended up with is not a model, not a tool, not even a workflow, not even achieving one goal, but it is a system that continuously thinks, acts, adapts, evolve, and rebuild, replan, and continuously learn from itself. And this leads to a fundamental shift. We are no longer designing functions. We are no longer building static softwares. Here we are designing behaviors. We are designing intelligence loops, and we need to be conscious while we are designing those behaviors, because behaviors, they are not only about executing one action or achieving one goal, because they have an impact in the long term of the agent as it goes in its lifetime. We know that agentic AI is not about making the model smarter. We know that it is more about building systems that can operate, evolve, collaborate in the world to achieve a shared vision, and hopefully it's a shared vision with a human vision, not only it's a separate AI vision. With this, we come to the end of our video for today. As you see on this roadmap, we have covered so far the basics, core components, frameworks and tools, and agentic capabilities today. We still have the agentic DevOps and software safety and governance to cover in the coming videos. And until the next one, as usual, thank you for your time and attention.